Hello, this video is about Math 3, Unit 3. It's an overview of the Polynomial Functions unit. Some of the details of this unit I've covered really in depth in the Math 3.1 video and also the Math 3.6 video. This is just an overview, so if you're looking for more detail, I encourage you to go on and listen to those videos afterwards. We're just going to thumb through the worksheets right now and kind of give you a view quickly of what's the same and what's different from what you've taught before. So 3.1 begins with an exploration in class, but at the end of the day, what they should have discovered was how the leading coefficient of a polynomial and its degree predict its end behavior. For instance, this parabola, this quadratic function, will start high and end high. It has a positive lead coefficient and a degree of 2, an even degree. And so this is the main topic of lesson 3.1. Again, there's a very thorough video on this lesson, so if you're uncomfortable with this topic, it's been a while since you've looked at that or taught that, I encourage you to listen to that video. You get some that are given to you in equation form, some that are given you graphical, some that are given to you in words. Again, this by the way will be on the next page. By the time you print it out, this error typo has been fixed since I ran these, but you will get a chance to look at these in a lot of different directions. At the end, there's a nice problem that is good to send home with the kids. Let them discover something and come back and use this 20 and 21 to launch your discussion at the beginning of the next class. So given that you know how the lead coefficient and the degree predict the end behavior of the function, we go on to 3.2. 3.2, the first couple, just review that, and we've added on figuring out the x and y intercepts and how multiplicity in effect affects the x-intercepts of the graph. So I'm going to show you that a little bit. Haven't done any video work on that until now. So first of all, the degree to something like this is, oops, sorry, let me pull this down so you can see it better, would be what you'd get if you multiplied all of that out. So I know that if I multiplied these two out, I would start with an x squared and a little bit more stuff. The very last term would be 2 times -7, so it would be -14. Wouldn't be very hard at all for me to multiply this out and see what it is, but I'm trying to show you if you didn't feel like multiplying it all out. Then you're going to distribute in an x squared to that, so I know that this function is going to start out x to the 4th and then a whole bunch of other stuff. The last term here is actually going to be a -14x squared. So the degree, the highest power of x that we're going to get is 4. That'll be my degree. The end behavior based upon this degree and lead coefficient, I have a positive lead coefficient of 1 and an even degree of 4. So that means just like a parabola or a quadratic, this will start high and end high. A positive lead coefficient, even degree. The x-intercepts we find by plugging in 0 for y. So if I plug in 0 for y or for f of x, I'm getting 0 equals, looking right here, x squared, x plus 2, x minus 7. And from here, you go ahead and explain it more fully to the kids, but you're going to get x equals 0, and x equals -2, and x equals 7. This came up as a factor one time, this came up as a factor one time, x actually came up as a factor twice. As a matter of fact, you could have written that as x times x plus 2 times x minus 7. So this x equals 0 we got twice, and that is then called multiplicity 2. I tell my students if they don't write anything, it's going to be assumed to be multiplicity 1, so they only have to write if they have something coming up twice or 3 times. They don't have to write it for every single thing. So the x-intercept, we plugged in 0 for y. The y-intercept will plug in 0 for x. So for this y-intercept, y, or f of x, will be 0 squared, 0 plus 2, times 0 minus 7, which will be 0 times 2 times -7, also known as 0. So this would be these were my x-intercepts. This is my y-intercept. So this little set of thoughts you're going to have to run through on pretty much every problem. Now I want to show you what happens, how we get from these facts to a graph. And so I have on this front page I have worked out all of those things for each problem already, and now we're going to talk about how that makes a graph. So just looking at this one right here, the degree is 3. If I multiply all that out, which means it's going to start low and end high, has a positive lead coefficient, a positive x to the third would be the first thing. And the x-intercepts, I got 1, -3, and 4. I'm going to put that on the x-axis. 1, -3, and 4. 1, 2, 3, 4. Those are all x-intercepts. None of them have a degree higher than 1 on the parentheses, an exponent higher than 1, so all of those are multiplicity 1. The y-intercept, after plugging in 0 for x, they got 12. I didn't put hash marks on the y-axis because sometimes you'll have a y-intercept that's 20 or 30, and so I just have the kids approximate, let's make this 12. That'll be 12. And now we know we're going to start low and end high. So as we start low, and come up to that y-intercept, we can come down and back up, and you will get the shape that you expected, starting low, ending high, by using all of those x-intercepts and that y-intercept. I want to point out a fact to you. It's okay if your kids don't really think deeply about this thought, but just in case it comes up, the maximum of this function doesn't really have to be at 12. This graph could go much higher and come back down to 12. So for instance, I'm going to write on this in pencil. This could come up like this and be coming back down by the time it got to 12 to do that. There's really no way without using calculus or a graphing calculator of finding out exactly what those maximums and minimums are. Now in our textbook, they do use a graphing calculator to calculate those maximum and minimums. We're not working on that right now in this unit, and so all you might be asked is how many maximums and minimums there are, how many maximums, how many minimums you see, and you won't be asked actually to calculate those. Those take calculus or a piece of technology. So this would be the graph. Either one of these two would be just fine graphs. We had got all the x-intercepts and y-intercepts, and that's what we're looking for, correct in behavior. When you get to something where there is a multiplicity, like these with 2, let me just show you what happens with those. So we're going to look at problem number 4 right here. And on problem number 4, if I multiplied this out, I'd have an x squared from this, and distributing that in, I'd have an x to the third. We would have a positive lead coefficient of 2 if we multiplied all that out. And so x to the third degree is 3, positive lead coefficient, start low, end high. The x-intercepts would be -4 and 2. So I'm going to put those on, -4 and 2. The multiplicity on the -4 is 2 because it has because it has 2 as an exponent. And it doesn't really matter whether this multiplicity is 2, 4, 6, 100. So long as it's an even multiplicity, it's going to behave the same. This is a great thing to have your students explore. What happens again if you did the exploration with Desmos on 3.1, it would be easy just to pull out your phone and do quickly, or plug in your computer and do quickly. If you change this graph from a squared right there to a 3rd degree, to a 4th degree, to a 5th degree, what happens at that x-intercept? It's a really nice quick exploration, and what you'll find is anytime that there's an even exponent right there, the graph will bounce off. And so this graph is starting low. Here it is. Oh, I forgot to put the y-intercept. The y-intercept that I worked out was -64, so very low. I'm just estimating, hey, that looks like -64. And it bounces right here off this multiplicity 2 spot, comes down and hits that y-intercept, and then it's going to cross here because we had an odd multiplicity. And so this would be the graph. So just to remind yourself, an even multiplicity bounces off the x-axis, and an odd multiplicity crosses the x-axis. It's a nice thing to have the kids think about why. They can really get that if they start plugging things in. When you plug in something to less than -4, like -5, here, when I plug in -5, I'm going to get a negative in there, but when I square it, it turns positive. When I plug in something over here like negative 1 or negative 2, I'm going to get a positive, but when I square it, it comes out positive. So that squared is not changing this sign. And then on this one, plugging in those numbers makes it a negative, so this is staying negative. So because of the squared, the sign isn't changing when you pass that x-intercept. So anyway, that's what's happening on these. Now that you know what the multiplicity does with the graph, that's just pretty much what you're going to be practicing. So on one like this, just to give you an answer really quick, you can check. I had a third degree that was negative lead coefficient, so it's going to start high and low. The x-intercepts were 0 and 3. 0 had a multiplicity 2, so there's going to be a bounce over here. 3 had a multiplicity 1, so there's going to be a cross. And I'm going to start, and my y-intercept was 0. I'm going to start high. I'm going to bounce off that, and then I'm going to cross and end low. Starts high, ends low, yep. X-intercept bounces, yep. X-intercept crosses, yep. Y-intercept 0, yep. And so you'll get through each one of those graphs. And so that's what's going on with this. This is really going to repeat every single day of the unit, this graphing. Here's a couple more of those. Then here at the end, they have you sketch the function and label points. Here the focus is about shifting. When we add 3, the graph is going to shift up. When we add 3 on the inside, remember we learned the graph is going to shift the opposite direction, so it's going to shift horizontally. And when we put a negative sign in front, the graph is going to flip over. And so this little section right here is on shifts of functions, something we learned in the previous chapters. So this is still coming back, a theme throughout the first semester. On worksheet 3, we're going to work on writing equations. There should be another video on that, so I'm not going to talk too much about that now, but what I'm expecting them to see is that here I have a spot where I'm crossing, here I have a spot where I'm crossing, here I have a spot where I'm crossing. So as I start to make this function, I'm not really sure what number might be in front. I'm going to put an A for that. But then this is my 0, so my factor should be x plus 2 with an odd exponent, x plus 0, or minus 0 with an odd exponent, and x minus 3 with an odd exponent. The 0 you could move to the front. Since it says, let me write this down. Since it says write an equation for the polynomial graph shown, any number that they had in that A spot, most likely 1, but if their lucky number is 17 and they want to put that there, that would be fine. In this case though, one thing that they need to think about is this is starting high and ending low, which means in this case A is negative. So if they want to put a number in that spot, they need to put a negative number. If they want to put a variable, they need to say whether A is a positive or negative number that it's representing. Okay, so that's what's going on each of these. When it says write the equation, the difference for that is that you'll actually have to find that value of A. So let's just practice this one again. I have a cross, and a cross. I'd like to actually pick one where it's not going through 0, 0, because sometimes those are a little easier. Let's try this one. I have a bounce, a cross, and a cross. So my x-intercepts, I don't know what my lead coefficient is, but my x-intercepts are x plus 1 with a bounce. I'm going to put a squared on that. X minus 1 with a cross. And, oh, I'm sorry, I'm off screen. And here, x minus 2. So now to figure out exactly what A is, because I'm wanting the exact equation for this, I'm going to use this point, and this point is the point 0, negative 3. X is 0, y is negative 3. So I'm going to put negative 3 in for y. A I don't know. I'm going to put 0 for x, all the x's. So I'll have negative 3 equals A times 1 squared, which is 1, times negative 1 times negative 2. So really I have negative 3 equals negative 2a. That's a negative sign, so positive 2a. I'm going to divide I'll have that a is negative 3/2. My answer to this problem then will be this equation with the negative 3/2 there. Y equals negative 3/2 x plus 1 squared x minus 1 x minus 2. This is the correct equation for this graph. So that y-intercept being exact lets me figure out what a would be. This one up here, where there is no y-intercept, leaves it kind of open. I'm not exactly sure what a was. All right, so that's what's going on in this one of writing equations. And then we get to a section of the unit where most of it is really about different techniques for factoring. Once things are factored, you can graph like we did in 3.2. So first they need to factor out a greatest common factor and then factor completely. And once they've done that, they're going to be able to graph this. So this is going to have x-intercepts of 0, 4, and negative 4, all with multiplicity 1. So here they are. And it's a third degree, start low, end high, with a positive lead coefficient. And the y-intercept on this, plugging in 0 for x, is going to be 0. So it's the same spot. So I'll start low and end high, and that would be my graph. And so on each of these, once you finish factoring, you will be able to graph, going through the same steps again. Here, notice is a quadratic form polynomial, so it's going to factor then to continue to have difference of squares and be factored more. Here again is one where first they have to factor out a greatest common factor, and then they have to factor more, factor completely. In their factoring experience during Math 2, they didn't have too many of these where they had to keep factoring, and so this is a little bit of a push for them to have to continue factoring. I don't think any of the factoring is especially difficult on this page, however. And then it will ask you to do the graph and just ask how many relative maximums there were, how many relative minimums, answer those types of questions. The next worksheet, 3.5, is about factoring by grouping. Now, this should be really familiar. Many of these problems were straight out of the initiative materials for Algebra 2, and this is just a lesson on factoring by grouping. And then this is using factoring by grouping to go ahead and do our graphing of polynomial functions. So if I was teaching Math 3 honors, I might not do all of these. I might decide to do odds or something like that. And then here we have the factor by grouping. Several of them, though, again, have first, here you go, first a greatest common factor to take out, and then factor by grouping to get more. And on this one, I had an x squared minus 4, which I then factored again. On this one, I didn't notice I had a greatest common factor to take out, so I factored by grouping first. Then I realized I needed to take out an x here. And then I realized I could factor more, so I actually ended up quite a bit of factoring on that problem. And so lots of these will be more challenging with several levels of factoring before you get finished and actually do the graph. From there, we're going to go to factoring using division. Most of the time we'll actually use synthetic division, and there's a worksheet on, there's a video on this entire lesson. But I just want you to notice that eventually we get to, we'll divide by this 4, use that to factor completely, get our x-intercepts, get our y-intercept, and make our graph. This entire worksheet will cover again. And the very last worksheet in here is on factoring with sum and difference of cubes. So again, this is real traditional right here. Once they factor the sum and difference of cubes, then they have a trinomial that can never factor. And so when we set to find the x-intercept, set y equal to 0, you'll get one piece that you can find, and the other part you will find that it's not factorable. And as they use quadratic formula to solve that, they will always get an imaginary piece in there every time. And in fact, the answers look very similar one after the other, keep having an I root 3 as part of the answer. And so they learn real zeros. This is our real 0, and these are our imaginary zeros. And this relates to what they did in Unit 2, where they found when they did quadratic formula with a second degree polynomial that they got no x-intercepts. So these two will not be x-intercepts that show on the graph. This would be the only one that shows on the graph. We don't have them graph on the sum and difference of cubes problems. There are more things to those graphs than what we know how to do in this class, but we did want to expose them. What if you have we wanted to expose them to factoring sum and difference of cubes, and what happens if you have an imaginary root, if you have an imaginary 0 when you're trying to solve for x-intercepts and realize there's only one of those. I probably would pull out my calculator and graph them and see, look, that's the only place it crosses the x-axis. That's consistent with what we did in the last chapter, and so that's what's going on with those. Besides these 7 worksheets, there's multiple tasks in the unit. The one task on weather is really pretty essential to survive the test. Of the other tasks, you might pick and choose a little bit what you would like to do. I would do at least one other one. There's an entire video about the tasks, so you can kind of preview those and see which ones you would have time to do. As many as you can fit in, the better. But if you're behind, this is a place where you could skip one or maybe even 2 of the tasks and still be able to survive the test. All right, I wish you the best of luck on this unit, and enjoy, and I'll see you later.